we are going to construct, because we are proving a theorem which states that there's a theorem there. Yeah? So we say if you are using colored pens, then you can construct with a solid line. Then you construct OR, and then you also try to construct OS. So we'll say for you joining these two, so you join OR and OS. Now, what we call OR and OS? It's a line from the center to a circumference. What we call a line from the center to a circumference? Radius. If it's one, it's called the radius. Okay? If there are two, what do we call them? Call them radii. Now, from here onwards, we are trying to prove. What are we trying to prove? We're trying to prove that R is going to be equal to our to TS. What are we trying to prove? We're trying to prove this line from R to T is going to be equal to T to our to S. As I'm saying here, we are going to say once we construct, we are going to have triangle OTR, and then we're also going to have triangle OTS. Now, in triangle OTR and triangle OTS, then we're going to put our statements on the left-hand side and then our reasoning on the right-hand side. Now, if you look here, even if they didn't say this, we know what is going to be this angle. What is going to be our T1? 90 degrees. Now, why is T1 90 degrees? It's given. Yeah, T1 is equaling to T2, which is 90 degrees, because these things here, they were what they were given. We are told. In fact, if you don't want to say which it's given, that's the time. If you don't want to say which is given, you can use the following reason. The reason which is given here, you can say to them, okay, it's because we have OT, which is perpendicular to what to RTS. The reason why this thing here is equal to 90 degrees is because those two things are what are perpendicular to each other. What else can we say? In these two triangles again, let's look at these two triangles. I will make this one to be red. And then let's make the other one to be green. As you can see here, there is a line which has both red and green. Okay? In these two triangles, we have triangle OTR and then we have triangle OTS. There is a triangle which possesses red and green. There is the line which has green and red. Which line is that? So we'll say, okay, but now it means we have a line which appears in both triangles, which is OT is going to be equal to OT because it's both red and what and green. Why is this line? Why is OT going to be equal to OT? It's because it's what it's common. It appears both on triangle OTR and then also on triangle OTS. We still good then. Now, what else can we say then? What else can we say? This is not there, by the way. This is not there. That's what we are trying to prove. And then from here onwards, we can then go and say, but now this here is a radius, and then this one here is also what? A radius. Meaning OR is going to be equal to what? To OS. Why are we saying that? Equal. So because we have equal radius. Are we still together? Yes. Now, these things, guys, they are congruent. What do we mean when we say two things are congruent? They are congruent, it means they are equal in shape and what and size. They are equal in shape and what and size. Then we can come and say, but now triangle OTR is going to be congruent to triangle O. Is going to be congruent to triangle OTS. How did we prove our congruence? We state everything that we've written here. Now, how did we prove this? We proved it by using a right a hypotenuse and a what and a side. So we've used the right angle, a hypotenuse, and a what and a side. So this is a hypotenuse. Remember, any side which is opposite 90 degrees, we call it a hypotenuse. Okay? So because we have a right angle, hypotenuse, and a side, then you could have said you've used this one. Therefore, if these two things are congruent, again, this one is equal to this one. Can you see that? This person is equal to this person. The only two people who are not equal are those two. Because these two things are congruent to each other, what then remains is that RT is going to be equal to what? To TS. And then the reason why we are saying that is because triangle OTR is congruent to triangle OTS. This is the formal proof of how we prove this one. And then we can then come and do the following here. Yeah? You don't see what? The reason why these two things are equal is because these two triangles are congruent to one another. For the fact that the triangles are congruent to one another, it makes this side and this side to be equal. And then for doing something like this is going to be 5 marks. Then you can come and do the following.